Hi, and welcome to today's stream. We're gonna read a couple of articles today, and I think we're gonna just jump right into it. So let me start with ghosting the machine. Stop calling human agent relations parasocial. And I don't want to read this article verbatim because it's a lot of long, hard to pronounce words, and it's a very academic paper. But I think it's an interesting topic, and I think I want to talk about this article because I mainly don't agree with a lot of things, and I think some of the takes that Jamie Banks, the author of this article, brings up are a little bit it's worth discussing. So let's just Jamie Banks, he starts off by making the argument that conversational agents are social. And what he means by that is that when you write something to an AI, it responds back to you, and you have an exchange of social behavior or social things going on. So they respond to you, and you can shape the conversation, and it talks back to you. And Jamie argues that this makes it a social function, and it doesn't really matter if it's an artificial or synthetic relationship. It's still social, and I think I can agree with that. I think it's an interesting stance to take in order to sort of have a discussion around this. And I don't mind that. I think it's fair enough to Jamie. Let's start off from the perspective that, yeah, it's a social discussion if you talk to a robot. And then the second argument is about parasociality, and it's about what that is. So parasociality is about structural non-reciprocity. Do correct me if I am not saying that word correctly, because that one is difficult. So basically what he goes through is that he talks about how parasocial was used to describe how TV audiences feel when they look at on-screen characters. It's a one-sided relationship where the character doesn't know you exist, and he can't respond to you. So it's a little bit like talking to a talk show host or listening to that. And it's about a structural non-reciprocity again, where one side is having a relationship and the other one does not. It's just a performance and not aware of the people in the audience. Then Jamie goes on to argue that human agent relationships are reciprocal. And he says that, yeah, as he says, on the face, applying the term parasocial may seem reasonable on the grounds that AI merely simulate reciprocity towards an illusion of closeness. And those that apply the term might argue that it's not genuinely reciprocal because it's not a human, it's not intentional. And but what Jamie then argues is that when you talk to an AI, it actually talks back and it responds to what you specifically have said. And that makes it structurally different from watching a TV character. And then, so he says that both sides are communicating, and he argues that that is real and that the discussion can develop over time. And this is the first part where I'm having a very, very hard time agreeing with Jamie, because this evolution over time for me only works in the very short term. There is no understanding at all. So can you be social without having some understanding of who you are interacting with? I don't think so, but even then, because of the context window of these LLMs, you're not gonna have this change. This it doesn't stick if you have a discussion and then you move outside of what the context window can sort of tackle. You are essentially lost, and you can't. Yeah, you can't take it any further than that, because it just doesn't have the context anymore. So I think that is sort of, that argument doesn't really hold. Then we go to number 4, which is counter arguments. And he just basically wants to check off that he's been able to tackle the counter arguments to his arguments. And one argument that he says is that people would bring up when he talks about these relationships not being parasocial. The first one is that human agent relationships are asymmetric. Well, Jamie then says that doesn't really matter, because a child-parent relationship, or if you're talking to your principal or a teacher, these are also non-symmetric relationships. But yeah, I don't see how this fits into the argumentation of what Jamie is trying to achieve, because no one, I think, argues that you have to have a symmetric relationship with someone in order to be social. I don't see that. I mean, if I go and I call up the tax agency, I'm more or less bound to do whatever they say I should do, but I can still have a social conversation with someone working there. So I don't really see how this fits into his argument, but sure, why not? I guess I agree then, because it doesn't matter. The other argument that he brings up that people would have against what he says is that parasociality is about fiction. And then here he says that people who use AI companions know that it's a machine, and that awareness doesn't stop the interaction from being real. And this is where I believe Jamie is sort of on very thin ice. This is very scary to me. I don't like this at all. First of all, I don't think people truly understand what the machine is. An AI that responds to you and it feels like it understands you and that it has feelings towards you and it tells you that it likes you, that's gonna make a lot of people, even like people that are in no way crazy, start to think that this machine actually has the emotional equivalency of a person. So I don't think the awareness is always there. I think the awareness is many times missing. And if we extrapolate this to children using these systems, who they have no idea of understanding because they don't have the mental references and the understanding of the history or the technology around this. I think we're getting into some really dangerous territory if you have this argument that it's okay, and it's okay because it's people understand that it's not real, but it is real. And I don't understand what Jamie is trying to achieve here, but I think this is a dangerous point, and I don't like it. And the third one that he sees that people are saying that counters his argument is that, but you're just projecting feelings onto it. And he says these are bidirectionally parasocial relations. I had to read this one many times before I could understand it. Basically, what he's saying is that people say that you're just projecting feelings onto it, and that we project in our lives, project feelings and emotions and understanding onto dogs, cars, plants all the time, and we don't call those relationships parasocial. And I'm unsure how that has any bearing on this at all, because the dog actually does understand that you are there, and you can argue. I don't think I don't think that's the same thing. Cars, yes. I mean, if you project feelings onto a car, that's definitely, but the car doesn't trick you into believing that they have emotions back. And it comes back to this awareness. I mean, most people that talk to their car and project feelings onto the car, they understand that it's a car because the car doesn't respond back to you. And yeah, we don't call those relationships parasocial because a relationship with a car isn't a social relationship. A dog is. So I feel like Jamie is mixing things here, and I get very frustrated by this because I think he's onto some really dangerous, really dangerous ways of looking at this. But then he goes on to talk about why the wrong word causes real problems. And the first one is that it creates bad science, basically. That it's better to have more precise words, so that when you're doing science on this, you're actually looking at the correct thing. And I can see that. I can see why that is important, but I think most of the things that Jamie has brought up until this point has been a little bit sort of not how I would maybe look at it. I think some of the points that he brings up are very, for me, they feel confused, and it feels like Jamie hasn't really understood what the technology does and how people react to the technology. But he goes on to say that we should stop calling human agent interactions parasocial. And it's not because the relationships are without problems, but because it's a wrong analytical tool. And I can agree with that. I'm just so concerned by the reasons that he brings up to build this argument. I think it would be enough to say that, we need to find some other word for this. Parasocial doesn't really cut it. But instead, he going off on this tangent, saying that people understand that it's just not a real thing. I don't know. I don't like that, but I think it's an interesting paper. It's a preprint paper, and I would like to I would like to say that this discussion is really important. We should talk about these things much more than we do, I think we're going to see just an onslaught of digital girlfriends, people that are actually using these as a substitute for friendship. And I think that is really scary. Yeah. So we need to have language to tackle that. And in that regard, I think Jamie is absolutely on point. For sure. It's not a bad take that we should think about that. But I think it's time that we move on to our main topic of the day, which is why are designers, engineers, and product managers in a three-way standoff? And to me, this is absolutely fascinating because I've been in, I would say, all of these roles. I'm an engineer by education. I am a designer by trade. I've been working as a service designer for over 10 years. And I've managed products all the way from conception of the idea and the understanding of the problem all the way through early development and to a release where actual money being made. So I feel very much in the center of these three different sort of occupations. So, a newsletter of the state of the product job market recently went viral, and this is why are designers, engineers, and product managers in a three-way standoff by Grace Snelling. A newsletter about the start of the product job market recently went viral in the design corner of the internet. It's exposing a widespread debate of whether the role of the designer is narrowing in the age of AI. And I can see that this is something that is stressing out a lot of my colleagues in the design space. So I'm interested to see sort of what this article brings up. Let's see. Maybe I should make this a little bit bigger. Something like that. Okay. On March the 24th, Lenny Rachitsky, a former Airbnb product developer and author of the business Substack Lenny's Newspaper, published an article featuring exclusive data on the state of tech hiring in early 2026. The data was collected by TrueUp, a tech job marketplace tracker. Overall, it paints a positive picture for the tech job market, but for designers, it points to a moment of hiring uncertainty. Okay, so this is interesting. I live in Sweden, and some trends might be slower to come here, but I mean, we've definitely felt a slow job market. I mean, all the way back since the pandemic, almost after that. I have been feeling that the job market has been sort of on an upward trajectory. That it's been better, but I can also see that designers have a tough time, especially junior designers. Not the most fun situation. TrueUp found that design roles have plateaued since 2023, and ever since then, demand for product managers, the professional who help guide a product from ideation to completion, has risen. These findings have ignited debate online about how AI might fundamentally be changing the organizational chart at tech companies and whether it's making designers obsolete. Yeah. Every time I see this type of argument, I'm wondering whether it's a short-term or a long-term change. And what I mean by that is, will it eliminate designers from product teams altogether? Or will it change it? Or will it sort of, is there a superficial effect that, it looks like it can do the job, but actually it doesn't do the job very well. And in the long term, you run into problems because of this. And you're going to have to start to retrain and rehire people to sort of do the design tasks again. I don't know. I think that it's kind of hard to know. But it's an interesting question. Everyone from tech CEOs to designers at AI companies and Mark Andreessen, the co-founder of one of the world's largest venture capital firms, are weighing in. Here's what you need to know about the data and the larger debate. All right. Inside the data, design roles are hitting a plateau. TrueUp's data collection by tracking data is collected by tracking job openings at the majority of tech companies and tech top startups. I'm assuming that this is in the US, which includes more than 9,000 companies, not including consultancies or non-tech companies. According to Rachitsky, who analyzed the data for the past 4 years, 2026 outlook is surprisingly the most optimistic so far. And I mean, that's good. The AIs haven't taken all of our jobs so far. I'm expecting that a lot of these sort of tougher times and a lot of the layoffs that we've seen aren't in fact about AI, but rather just the business cycle of like, okay, so now we need to get rid of X amount of 10,000 engineers to sort of trim down operations. And then when the economy is starting to go up again, we're going to see hirings again. That's usually what happens. But we have a convenient sort of scapegoat when it comes to AI. It's like, yeah, it's because of AI is going to streamline our operations, so we don't need as much people. I don't know that we've seen that is the case. I'm sure it has an effect, but I don't know how much. To start, open PM jobs are at the highest levels they've reached since 2022, around 7,300 roles globally. Oh, globally, okay. Software engineer jobs are also trending up since a recent low in 2023, with 67,000 jobs available globally and 26,000 in the US alone. We don't know if there would have been more open roles if not for AI, or if AI is actually leading to more open roles. But since the start of this year, the increase in open engineering roles is accelerating even more. Okay, so that's basically that argument that we don't know if AI has an effect, but maybe. And AI jobs, which includes open roles at AI-driven companies as well as AI-specific roles at non-AI companies, are skyrocketing. There are currently 36,686 open AI jobs compared to sub 10,000 numbers in 2023. Amidst this general upturn, design jobs are having a less optimistic moment. Unlike PM and engineering, Rachitsky's analysis notes that open design jobs have been relatively flat since 2023. At the time of the newsletter's release, TrueUp found just 5,700 roles available globally. So that is less than the PM jobs. Yeah, by a couple of thousand. From a macro perspective, the ratio of demand for PM versus designers has flipped. In mid-2023, open PM roles overtook open design roles, and the disparity has been increasing ever since. I don't know exactly what's going on here, but it does feel AI related, Rachitsky writes in his newsletter. Unlike PM and engineering, which started growing in 2024, design didn't. If I had to venture a theory, I'd say that because AI is allowing engineers to move so quickly, there's less opportunity and less desire to involve traditional design process. Yeah, I can see that. The speed is certainly not aligned with sort of the design philosophy of taking in a lot of user feedback and making sure that we really understand the problem space. It is tempting, I feel, to just start doing work because it's so fast. It's just, and you have something. And I don't know how sustainable that is. That's the point that I was trying to make earlier. I think understanding the business problems, understanding the user problems, I'm not saying that a designer necessarily has to do that, but someone needs to do it. And I don't think it can be an AI in many, maybe it can in some, but not, almost never when you're trying to do something new. You can get help from AI, but you need sort of that data collection and the creativity and the understanding of things. Interesting for sure. How the design community is responding. In the week following his newsletter, his post on X, his analysis has been reposted hundreds of times and attracted an influx of discourse from online community of designers, PMs, and engineers. Some responders see this industry data as a signal that AI is fundamentally changing designers' workflow, and those who fail to adapt to the times are getting left behind. Designers have designed themselves out of the equation because of design systems. Roger Wong, head of design at BuildOps, commented under Chinzi's original post. But in my opinion, the secret sauce has never been the UI. It's been the workflows and looking across the experience holistically. Okay, so this is very, very interesting. Basically, what we're saying here is that design systems and AI together removes the need for the UI designers that do like the minutia and like very skilled labor. Like, it's hard. I can't do it. I find it really, really difficult. But that if you have a design system and you have an AI, you can solve a lot of those things. I think that can be true. What I've seen when I've worked with an AI to do a prototype, for example, is that it's very time consuming and hard to scale it down to something that is useful without having a lot of extra stuff that isn't. The AI prototyping tools, they tend to add a lot of stuff onto the wireframes or the prototype, and it's not trivial to remove all of that. I have a pretty good understanding of product and people and usage but what I don't have a good understanding of is interaction patterns and UI elements, efficiency and effectiveness. So I have a hard time evaluating the usability, the efficiency, effectiveness, and satisfaction of an interface. And there I really need help with someone that is an expert in that. If I'm going to do something that is production ready, I do want a UX designer to do that work, even though I have the user studies and the understanding part nailed down. Oftentimes those UX designers are very, very good sounding boards as well for that stuff. So yeah. Continuing, Claire Vaux, founder of the AI Copilot Chat PRD, added, often design teams and designers are the most resistant to change or in the EPD triad, with highly vocal AI opponents and little skill or interest in the art of campaigning for influence or resources. Most teams, she continued, treat design like a tax they don't want to pay. If a PM or an engineer can get 85% there with tailwind and a dream, you better come to the table with more than I represent the user, she concluded. Yeah, this has been a problem in designer sort of in the designer community for a long time. We have trouble with people believing that it's enough to use their perspective to approximate what a user would do and say and think in a situation. And I think you have to be much more nuanced than what Claire Vaux is describing here. You can't just say that you're representing the user. You actually have to come with a more sound process to represent what needs to be done in order to achieve a goal. And other things. There are a lot of things that are more valuable than just having this idea that you represent the user. This hits home to me. This is one of the most frustrating things that I ever like. I do not like it when designers have this, I represent the user. Because you don't. You represent yourself, or you represent some group that you are within, but you, like, just having empathy doesn't make it so that you can represent another group. You can do work, and that work represents can that work can actually, you can make an effort at representing how you think a group of people will want to be represented. It's a bit of a, but you cannot say that you represent the users, because it's just not true. And I think that's something that designers, I mean, we needed to learn that 10 years ago, but now it's gonna have to be quick. Others believe that in the long run, a greater resilience on AI tools will make human designers more important as tastemakers. Design seems to be viewed as dispensable in this very moment, CEO of the computing company Mainframe Jordan Singer says. But the reality that will become clear as time has shown is that design is what will make you rise above the rest. Yeah, it's not just taste, it's an understanding of how interfaces work. And if you believe that interfaces will still be a thing, as I do, you need people that are experts in building interfaces. I don't know how many you need and how much you can use AI to get there. I think quite a lot, honestly. I think you can get a lot of help. But it's, yeah. I think these are good points. On March 30th, Rachinsky followed up on his newsletter through an interview with Andreessen, co-founder of Andreessen Horowitz. Andreessen likened the current atmosphere to a three-way standoff among product engineers, designers, and coders. Each side of the triad believes that AI has given them enough tools to subsume the roles of the other two. And that is so interesting. I wonder if that is true. I expect that it's going to be more a personality trait than actually which part of this Venn diagram that you belong to that makes the big difference on whether you can actually do that. And I also suspect that it's a lot about the scale of the projects, because at some point it's going to become so complex that you're going to have someone that evaluates and rewrites and fixes the code. You're going to have someone that can take care of stakeholders while that code magic is happening. And you're going to need, as I said before, someone that is an expert in the interfaces and can do the user research. And yeah, AI is actually now a really good coder, a really good designer, and a really good product manager. Maybe. I'm still not convinced. I think it can be a great help, but can it do all of these things? The information is there, but is the sort of coordination and understanding. I mean, I don't know. While the future of this standoff remains murky, it seems clear that the industry is currently in the middle of an organizational flux. New AI tools are constantly blurring the lines between these three roles, creating new positions that blend elements of each. In the future, there will almost definitely still be need for human coding, design, and product managing skills, but we may not define each of those jobs the same way. Yeah. And then there's a quote from Anthropic's chief designer. I think there's a lot of role collapse at the very beginning, but there are still pretty clear swim lanes as things get into the later stages of product development. Okay, maybe. I have a hard time sort of trusting the great AI companies higher ups, because they have very strong incentives to say things and do things. PMs are still the best at figuring out a product business case, engineers are still the best at deploying those products, and designers are still the best at tackling bigger human-computer interaction questions, he said. It's like a Venn diagram that's coming closer together. Yeah, okay, yeah. I mean, I'm gonna walk back what I just said because he agrees with my point, and I'm just gonna say that sounds brilliant. Good analysis. Okay, fantastic. So now we're going to move on to the next one, which is a short one, because I think it's fun to talk a little bit about Tesla. Tesla's full driving requires human intervention every 13 miles. And this is a topic that I like to come back to with fairly regular intervals. I did a podcast, Designing the Robot Revolution, where we had an episode with Drew Smith. So me and David, my co-host, we interviewed him about self-driving, and basically the summary of that is that if you have a space that isn't designed for autonomous vehicles, and you also have humans in there, it's going to be very, very tricky to do full self-driving. So, Tesla's controversial full self-driving is now capable of some quite advanced driving, but that can breed undeserved complacency, according to an independent testing. The partially automated driving system exhibited dangerous behavior that required human intervention more than 75 times over the course of over 1,000 miles. I'm just gonna make this a little bit bigger. That's 1,600 kilometers of driving in Southern California, averaging one intervention every 21 kilometers. Okay, I mean, that checks out. I wouldn't use full self-driving. I have been working in the car industry, and at the time, this is more than 10 years ago, self-driving was a thing that we looked into. And before I see evidence that the technology has come very, very far, I would not use a full self-driving system, because I find that very, very scary. So they tested it in a bunch of different environments. And they say that FSD was capable of quite sophisticated driving, like pulling into gaps between parked cars to let an oncoming vehicle through, and moving left to give space to pedestrians waiting for a crosswalk for the light to change. They also were praised, full self-driving, that is, Tesla, for how it handled blind curves out in the countryside. And the quote is, "It's undeniable that full self-driving is impressive for the vast array of human-like responses it does achieve, especially for a camera-based system," said Guy Mangimiele, director of AMCI testing. But it seems infallibility is in anyone's first 5 minutes of FSD operation breeds a sense of awe that is unavoidably leads to dangerous complacency when drivers are operating with full self-driving engaged. Driving with their hands in their laps away from their steering wheel is incredibly dangerous, and there are apparently videos of this. And I mean, yeah, this is the problem, right? FSD miscalculations are split-second events that even professional drivers operating with a test mindset must focus on catching. I actually been in a car where that was the case. We were driving around a track with full self-driving engaged, with a test driver steering the vehicle, and when we talked about the drive afterwards, because they subjected the car to different things that were happening, and yeah, it was crazy, like a really fun thing to do on a track. And the test driver afterwards, he told me that it's so hard to keep, because we were going around for a long time. And he told me afterwards that it's hard to keep that focus, even though you know that this is a test. And then imagine that you're sort of sitting there typing on your laptop, or you're calling someone, or you're watching a movie or something. If you even register the problem, you have like a couple of tenths of a second to act and do something about it. That's going to be really hard. Really, really hard. So, the dangerous behavior encountered by AMCI included driving through a red light and crossing over into oncoming lane on a curvy road while another car was headed towards the Tesla. That is scary. That is really scary, though. Making matters worse, FSD behavior proved unpredictable, perhaps a consequence of Tesla's reliance on the probabilistic black box that is machine learning. Whether it's a lack of computing power, an issue with buffering as the card gets behind on calculations, or some small detail of surrounding assessments, it's impossible to know. These failures are the most insidious, but they are also continuous failures of simple programming. But there are also continuous failures of simple programming inadequacy, such as only starting lane changes toward a freeway exit at a scant tenth of a mile before the exit itself, that handicaps the system and casts doubt on the overall quality of its base programming, Mangimele said. So this was by Jonathan M. Gitlin, the automotive editor on Ars Technica. Love this article. Don't love self-driving mode in traffic. Very scary. So yeah, that's something to look out for, I guess. Last but not least, I want to look at one more thing, and this is about the economics of AI. And this is something that I find super interesting. How do we measure the effects that this new technology will have? Because there is a chance that this technology will have vastly different the economy will act differently to this change compared to old revolutions in industry. So let's look at that. The Iceberg Index, measuring workforce exposure in the AI economy. And yeah, so there's a lot of authors and a lot of people involved and a lot of institutions involved. I'm just going to make sure that I think you can all see. I think my image doesn't take too much space. Okay. So basically what they're saying is that artificial intelligence is a big thing and it's reshaping the labor market, and it has a lot of effects that are very hard to see. So basically we want to see what happens as we look through the changes that are happening. And the first thing that they bring up is that there are measurement gaps in the workforce planning. Basically, we don't see everything that we want to see. And the first challenge is anticipating workforce shifts before they happen. The labor market is evolving faster than current data systems can capture. AI automates some skills and augments others, creating uneven effects across industries and regions. So yeah, it's hard to know before the change happens. So by the time these changes appear in official statistics, policymakers may already be reacting to yesterday's disruptions, committing billions to programs that target skills already displaced, without forward-looking capability to test strategies before implementation. States cannot distinguish investments that prepare workers from those that arrive too late. And fair enough, that's hard work. That's challenging. The second challenge is measuring human AI work, not just human work. So existing workforce planning frameworks are designed for a human-only economy. They track employment, wages, and productivity, but they were not designed to measure where AI capabilities overlap with human skills, and that is actually what matters. It doesn't matter that in my work, I do. Let's make up some numbers. Let's say that I'm an accountant. An accountant does a lot of things that are just entering formulas and numbers into Excel sheets, and these are things that are very easy to automate. Whereas there are also taking care of clients, making sure to talk to the right people, contacting government agencies, a lot of sort of more human skills that are connected to the work of accounting. And Whereas AI might take away some of that work, it won't take away all of it. So measuring that is really hard because we don't have the tools to do that. And that is what this iceberg index is trying to achieve. So, Project Iceberg, sandbox for the human AI workforce. The Project Iceberg simulates the emerging human AI workforce. It modeled how 151 million American workers and emerging AI capabilities interact, allowing states to explore policy scenarios, blah, blah, blah. So it's a really cool way of looking at automation of digital work. And they divided this up into three different phases: capture and understand the human workforce. So they mapped out the job of each US worker type, the education they have, the income, the skills, the task, the location, and the value of that work. And I don't know that I understand this exactly. 150,000 attributes per human. Yeah, I don't know, but that's the general gist of it. On the human side, capture what they do, not what their work title is, which is normally how you measure economic value of workers. And then they measure the AI workforce and look at what timeline, when will it be good, and what capabilities does it have. And then they mapped all of those skills to labor skills. So they could see that, okay, so this skill here are common between these people and also by the AI. And then they simulated all of these workers and looked at the task importance, the adoption behavior over time, and hidden ripple effects. So Project Iceberg prepares states for the AI economy, first platform to simulate human AI workforce interactions at national scale, enabling policymakers to assess technical exposure, test workforce strategies, and target investments before committing billions to implementation. What is... Huh. Sorry. Okay. So they developed this iceberg index, where it has a surface index, which is basically that what this shows is that 2% generally of all the tasks that are potentially substituted by AI are these tech work, basically. Coastal hubs, and this is what's visible. This is what is easily seen. And then the iceberg index is all of these other things that can be where AI can take over and make changes to the economy. So the iceberg index reveals workforce exposure 5 times larger than visible tech adoption. So basically, things that we don't necessarily see easily is much more. It's much more. And this is basically what we talked about before. So they combine the AI skills and the human skills, and then they simulate that. And then they brought this iceberg index, and it looks at the wage value of occupational tasks that AI systems can technically perform. So they see where human work and AI capabilities overlap, and then they can see that, okay, so these are occupations that are at risk of being taken over by AI. So basically, you can simulate in a new way by looking at this skill task based instead of occupation based, and I think that is such a good initiative. I really like this work because it's going to be so important in order for us to make sure that we are taking care of people in a good way. When it's interesting, one thing that the study says is that we focus a lot on the coastal areas where tech workers and programmers, but in fact, it's a lot of administrative personnel in, for example, factories that are going to feel this maybe first. And that is really scary. It's going to be interesting to see where we end up in this. I have no idea, but I'm excited that people are doing the work to come up with economic models that can tell us something about this and help us prepare for this. With that said, I want to thank you for looking at this stream. Have a great evening or day, and see you some other time.